Kelsey Potts, and I'm going to be explaining problem 5 on our second Expert TA explainer video. So for this, our problem is a swimmer bounces almost straight up from a diving board and falls vertically feet first into a pool. She starts with a speed of 3.2 meters per second, and her takeoff point is 1.5 meters above the pool's surface. And you can see that here in the picture that I drew. So this is our person, and she's jumping straight up and into the pool, and then she's 1.5 meters off the ground, and then her speed is 3.2 meters per second. So for this, in part A, we want to find how long her feet are in the air in seconds, and then in part C, we want to find what her velocity is in meters per second when her feet actually finally hit the water. And for this, we assume that the vertical component of the velocity is positive in the upwards direction because she's jumping into the pool. So our strategy for solving this problem will be to first look at what we already know, like what they tell us in the problem, and then we can apply that information to actually solve the problem. So for this, we already know that the speed is 3.2 meters per second, or the initial velocity. And we also know that her takeoff point is 1.5 meters. So when actually solving this for part A, we can use this equation, and when you plug in the information that you're given, you plug in your takeoff point, which is the 1.5 meters, and then your speed, which is 3.2 meters per second, and then plus 1/2 times your acceleration, which is a constant variable, so that's always 9.8, times your time squared. And then once you solve, you then use the quadratic equation, and finally you will get that your time is 0.97 seconds, or that is how long it takes her to jump into the pool. And then some pitfalls with this problem is if your numbers get mixed up, so it is important to use units when solving so that you can help check your work. And then for part C, we use this equation, and when you plug it in, you plug in your initial velocity, which is the 3.2 meters per second, and plus your acceleration, 9.8, times the time that you found in part A, so you'll use the 0.97 seconds. And then when solving, you'll get a velocity of negative 6.3 meters per second. And then for this one, some pitfalls are if you assume that the initial velocity is the final velocity, or if you get those mixed up. So you want to be sure that you're using the speed as the initial velocity and you're finding the final velocity. So yeah, that is how to do number 5 of our Expert TA explainer video.